In this lecture, we are going to talk about static, limiting and kinetic friction. Now to understand that, let's conduct a small experiment. Here we have a block of mass m and it is kept on a rough surface and it is being pulled by a certain force F. Now, if I increase the value of F starting from 0, means basically if I don't apply any force, then the block won't move, right? But let's start increasing. I apply a force of, let's say, 1 Newton and I see that the block is not moving. Then I increase my force to 2 Newton, then 3 Newton and so on. I kept on increasing my force, but it did not move. At exactly 10 Newton, I observed that the block just starts to move. So if I see my experiment from 1 Newton to 10 Newton, let's say the block doesn't move. The block does not move from 1 Newton to 10 Newton. At 10 Newton, it just moves. So in this case, we can observe from 1 to 10 Newton, even if I am applying a force, the block is not moving, right? That means there must be some other force which is balancing my force. Now that force is our static friction. Means this type of friction exists when there is no relative motion between the surfaces in contact. Here there are two surfaces, one's lower surface of the block and the ground. Now ground is our rough surface and the block is not moving over the ground, right? That means if I am applying, let's say, 3 Newton, then there must be a frictional force which is equals to 3 Newton and it is balancing my force exactly. Now if I increase my force from 3 to 4 Newton or 5 Newton, then the friction also increases to 4 Newton and 5 Newton and so on. But in my experiment, I see that at 10 Newton, the block just starts to move. Means when I apply 10 Newton, there must be 10 Newton force here, but the block can move with constant velocity, right? Means even if the net force is 0, the block can move. Now this value of friction at which the block is just about to move means the maximum value of static friction is called limiting friction. This is the second term. So what is limiting friction? Now this is the value of friction at which the block just starts to move, or maximum value of static friction. Now once the block start to move, we can see that even if we apply a lesser force, let's say at 9.8 Newton, after starts moving, after the block moves, even if I apply a lesser force, still the block continues to move, right? That means once the block starts to move, the friction required to keep moving is little bit lesser than the limiting value. Here our limiting value was 10 Newton in our experiment, but with a lesser force, maybe 9.8 or 9.7, something like that. At a lesser force, even if I apply that force, the block will still keep on moving. And that amount of force is called kinetic friction. Now, if we theorize all of it, then the static friction is force of friction that exists before one surface slides over the other, or we can say when there is no relative motion between the surfaces in contact. This is very important. Static friction exists only when there is no relative motion between the surfaces in contact. Now for limiting friction, it is the maximum value of static friction. And about the kinetic friction, we can say it is the friction which exists when the block is moving, means there is relative motion. So here relative motion exists. We can say relative motion exists now. Then the type of friction is kinetic friction. If we show all these values in a graph, then according to our previous experiment, if we see the data, when I was applying 0 force, there was no frictional force because there was no tendency to move at all. But when I apply 1 Newton, then friction is also 1 Newton. When I apply, let's say, 3 Newton, then friction is also 3 Newton. So if I keep on increasing my applied force, then friction was increasing, but the block was not moving. So this straight line portion shows us that value. So this straight line portion stands for static part. static friction part, because here the block is not moving. Our external force is being balanced by the frictional force. At the maximum point of static friction, this is what we call, this value is what we call limiting friction. And then after that, after limiting friction, even if I still increase my force, still the kinetic friction value just drops from the static value. It just drops, means little bit lesser, but then it continues to be constant. Now here in the graph you can see I have written mu into n. What is this mu into n term? Now there comes the law of limiting friction. The law of limiting friction says that force of friction is directly proportional to the normal reaction between the surfaces in contact. Means if we have a block over a surface and the block's mass is, let's say, 10 kg, then there will be normal reaction of mg, which is equals to approximately 100 Newton. I have taken g equals to 10 here. Now this 100 Newton is our normal reaction. So the force of friction that can exist, maximum amount of force of friction, which is our limiting friction. So this force of friction value will be given by this law, and it says that the limiting friction is directly proportional to normal reaction. So Fr is proportional to n, or I can say Fr equals to mu n. The thing to remember here is friction Fr is not our any friction value. It is the limiting friction. This Fr is limiting value. Means this is the maximum possible value. We have to remember. This is the maximum possible friction. This is very important to remember. Friction at any time we cannot say is mu into n. Mu into n is the maximum possible friction that can exist between two surfaces. Now here this mu term is our coefficient of friction, which depends on the nature of surfaces in contact. It is basically constant for two surfaces, and while solving problems, mu value is given to us.